I'm going to go over a few problems from the Math 3 Unit 6 Worksheet 8, starting with number 3. Here, looking at this equation, we have a translation down 1, that's at minus 1 from 0, 0, so that's our center of our graph. I'm going to create a table of values. We know 1's at 0, negative 1. And I'm going to pick some other values that I can take the cube root of. For example, 1, when I plug in a 1, I end up with negative 2. If I plug in 8, I end up with negative 3. So it moves down and to the right, and pick some values to the left of 0 here. If I plug in a negative 1, I could take the cube root of negative 1, and we end up with a double negative here. So negative 1, 0. And I could plug in a negative 8. Again, a double negative, which gives me 2 minus 1, or 1. So roughly there. So we have a general shape of this graph. The cube root function goes as far left and far right as we want, also drops down as low or as high as we want. So both the domain and range are going to be from negative infinity to infinity. Take a look at number 5. Here we have a translation right 2 units, up 1 unit from 0, 0. So that's our center of our graph. I'll put that on here. So we got 2, 1. Now I'm going to pick some other values to get a general shape of this. I'll pick a 3. We get negative 2, cube root of 1, plus 1. Cube root of 1 is 1. This is negative 2 plus 1, which is negative 1. So 3, negative 1. So it's going to go down and to the right. And then I'll pick negative 1. Actually, positive 1. And I get negative 2, cube root of 1 minus 2, and then plus 1. Cube root of negative 1 is negative 1. Negative 2 times negative 1 is positive 2. So we end up with 3. So 1, positive 3. Oops. And you know what I'm noticing? That I graphed my second point wrong. So it should be at 3, negative 1, which is here. And this one is at 1, positive 3, which is up here. So that's what our graph should look like. Domain and range, as far left and as far right, so as we want. So negative infinity to infinity for the range, the domain, and it goes as low and as high as we'd like, so negative infinity to positive infinity for the range. Lastly, let's take a look at number 7. We're asked to sketch the graph first for each of the following, and then find or solve for the indicated information, which is A all the way through D in this case. So starting with a graph, we got g of x is the negative cube root of x plus 2 plus 1. And so we go left 2, up 1 from 0, 0 to get the center of our graph. Let's get a couple more points here. If I plug in a negative 1, I get negative cube root, negative 1 plus 2 plus 1, which is negative 1 plus 1, or 0. So it's coming down and to the right. And let's try another one at negative 3. Which is 1 plus 1, or 2. So negative 3, 2. And here we have a sketch of our graph. Domain and range are always the same for these cube root functions, negative infinity to infinity. The x-intercept we see in the graph is at negative 1, 0. If you didn't choose that point to graph, you can solve for that by plugging in 0 for g of x, subtracting 1, or you can add the cube root of x plus 1 to both sides of the equation. Cube both sides. Raise both sides to the third power, and you get x plus 1 equals 1 to the third power, which is still 1. And then you subtract 1, you get x equals 0. But that's not matching with my graph because I copied the question down, and this should be an x plus 2, which is going to give me x equals negative 1, which is what we see in our graph. For the y-intercept, that I don't know for sure. I don't see a lattice point that my graph is going through on the y-axis, but we can find out by plugging in 0 for x. So if I plug in 0 for x, I get g of 0 is 1 minus the cube root of 0 plus 2, which is 1 minus the cube root of 2. And without a calculator, that's about as far as you're going to be able to go. Part C is asking for the open interval. The open interval means only use parentheses where g is decreasing. As you trace our graph from left to right, you see it's decreasing everywhere. And so I'm just going to copy the domain down, negative infinity to positive infinity. Next, the open interval where g is negative. G is negative where it's below the x-axis. So it starts at the x-intercept and to the right of the x-intercept. So below the x-axis is what we're looking for. Again, keep it an open interval, only use parentheses here. And so starting at the x-axis, or the x-intercept at negative 1, all the way to the right to infinity.